Hello, my name is Areeb, and today I will be presenting to you my application submission for the MIT App Inventor application platform for the Prototyping Tools Web and Mobile Applications course. I've built a health fitness tracking app, so let's begin the presentation. So the cloud-based fitness and health tracker app is a multi-screen app which will allow an individual to track their fitness and health data. It is specifically intended for individuals with type 2 diabetes, hypertension, or obesity who are at risk of severe health degradation due to a sedentary lifestyle. These individuals are typically placed on a strict regimen of fitness activity, and they have to track certain vitals to ensure that their health is maintained. The application will also enable users to use a voice assistant to search new workouts and other useful information on Google. The cloud-based health tracking assistant app will enable users to input their health information after a workout, such as oxygen, pulse, and sugar levels, save user health stats in a tiny WebDB database so they can view it later, utilize the phone's thermometer sensor and location sensor in case of medical emergencies, and as we are tracking and inputting private and personal fitness-related data, we will integrate user authentication, such as sign up and login, using Firebase to keep access to this data secure. The user will be able to utilize a voice assistant using MIT App Inventor's speech recognition, and the user can use the voice assistant with speech recognition combined with speech-to-text conversion to search and recommend new workouts on Google. So now let's take a look at our approach. As you can see here, we have multiple screens. Our initial screen is the login screen where the user will be prompted to enter their username and password. If they enter an incorrect username or password, a message will pop up informing them that that username or password was incorrect, and they will be prompted to enter in a correct one. If they enter a correct username and password, they will then proceed to the next screen, which is the main menu, and it will say, "Welcome to the fitness app." And they have a choice. They can choose to add a new entry of their health information after completing a workout, or they can choose to use the voice assistant. The next two screens are the voice assistant as well as the health data tracking aspect. So in the voice assistant over here, they can enter their name, and the voice assistant will recognize them by name and will talk to them by their name. And they can press the microphone button, and they can use their voice, their speech, to talk to the robot, which will be able to recognize what they're saying. And if it doesn't understand or doesn't have the answer to their question, it will then do a quick Google search to find the answer and present that to them. On the health data screen on the far right, we see here that the user will be prompted to enter their sugar, blood, and those metrics, their pulse. And once they add that data point into the database, it will then be saved on a tiny WebDB. And they can then track it later on, and they can see those entries after a while. So we had three custom defined procedures. One was the speak message procedure. So what this basically does is that it calls a text-to-speech built-in procedure and allows the user to speak to the voice assistant on the application. We also have the authentication procedure that we've built over here. This basically ensures that if the user has entered an incorrect password or an incorrect username, then they are directed or prompted in the appropriate way to enter the correct credentials. And over here, we have the Robo Q&A, which basically means this procedure will search and check if a user has asked questions that it knows. So these are some of the pre-built-in questions. How are you? It will say, "I'm fine, hope you are too." Who is your creator? It will say, "Areeb Khwaja," which is myself, is my creator. What is my location, where it can sense the location? What is the temperature? And then if it doesn't, if it gets a question which don't fit these questions, then it will use Web Viewer to search on Google to identify the query that the user is looking for and present that query to the user. Other significant elements of our application include conditions and loops. So we've used several if-else conditions. We used many local and global variables. We utilized one list for loading health data onto the tiny WebDB. Data persistence in our application is evident through the storage of health data for later viewing. And we utilize two sensors, temperature and location. While these sensors were not originally planned, they can help users track their own temperature and location in health-related emergency situations when they can ask the voice assistant. Initial challenges that I faced when developing this application was I recognized the importance of planning. So when I had originally started creating this application, I had started building from a specific screen, the third screen, the screen with the two options to choose from. And that screen was not the login screen. And I realized that on MIT App Inventor, you cannot change the order of the screen very easily. So I had already written the code or already developed the code for that screen as well as the login screen separately. And so I had to figure out how to change the screen order. And that took a little bit of time for me. And so I realized the importance of properly planning out the implementation. And now I'd like to point out, as we are using TinyWebDB for storing the health data, which is very private and confidential, and we have used the Firebase authentication service to ensure that users can only access their account on that app. Anyone can really easily access that sensitive and private data if they know the correct tag to use, because it is accessible to all users who are using TinyWebDB. So it would be much wiser to locally store this data on the user's phone. However, this comes at its own cost. For one, they cannot share that data easily with doctors and other medical professionals. However, for the sake of the scope of this project for this class, because we were instructed to use TinyWebDB or Firebase, I chose to use one of these. But if I were to build a real life application, it would either have much more security and safety and privacy enabled, or it would be locally stored on the user's own device. So this was a great learning opportunity for me. Thank you, and I hope you enjoy my application. Now I will be showing you a demo of what my app functions like. So as you can see here, this is the login and sign up screen. Over here, I will have to enter my username and password. So I will first enter an incorrect username and password. Let's say my name is Ariba, and my password can be anything. If I try to log in, it will display a message saying wrong username and or password, telling the user to fix their username or password. Now I will enter my correct username or password, which has been stored on the Firebase database, because we're using the Firebase authentication service. So when I click login now, it will allow me to go to my main screen, my main page. And now I can choose, it says welcome to the fitness app. This fitness app will help you track progress through your workouts. And so now I can choose to add a new entry. Now you can see here in my new entry, this is my health data information. So it asks me for my oxygen, my pulse, and my sugar. These are data that I have to record after a workout or before a workout to make sure that I am following the routine of my fitness exercise so that I can stay healthy. So I've already entered a few data points in here, but let's say if I did an exercise, I wanted to enter something in again. I'm just going to enter some random values here. And if I click add, this value will now be added at the very bottom. You can see here, oxygen is 60, pulse is 55, and sugar is 100. These are some random values. I don't know what the appropriate values would be. Then I can click back, and I can go back to the main screen, and then I can use my AI assistant, voice assistant. So when I click here, it will say to enter your name. I can enter my name. And then I can click the microphone button to use the voice speech recognition to talk to the application. Show me how to do jumping jacks. Try again. Show me how to do jumping jacks. Show me how to do jumping jacks. Okay, I think the audio on this is disabled while I'm recording on my phone. That is why it can't hear the audio. But when you speak through the microphone on this screen, it will quickly search on Google's search API and find the relevant queries to your answer if it can't answer your question directly, and then it will respond back. So because I'm using Zoom, and if my voice is being recorded on Zoom, the audio is not being recorded through the microphone here. But if you were to use it yourself, it would let you use the Google search API to find the relevant query. And I can click back, and that is my application. It is meant to be used as a healthcare tracking application for individuals with obesity, hypertension, or type 2 diabetes, because they are usually put on a training or fitness regimen to ensure that their health and well-being is maintained, and they have to track these specific health metrics. And so this is something that will help them track that as well. Thank you.